Okay, good morning once again. Today we're going to continue our discussion on linear regression. Last time, what we did was to regress our dependent variable hourly wage, and we'd like to explain the variability of hourly wage on a specific variable, education. Now, initially, why did we choose education? We chose education because when we plotted the correlation between your continuous variable, which is your dependent variable, with the other continuous variables, independent variable, we saw that education had the highest correlation with hourly wage, di ba? Kinuha natin yung correlation ng education with hourly wage, and we saw that it had the highest correlation. So if we're going to make use of a simple linear regression, ang pinakamagandang candidate na gamitin natin na predictor is education. Okay? However, what we saw was, sige, let me, nawala kasi guys yung file na we were working on. No? Sorry about that. Okay, so let me just run yung okay. I'm just using an old file. Okay, so what we did was to regress. Let me find that. No? Okay, simple regression. Now, we said that there are factors here, there are variables here in our data set that are factors. Categorical siya. Race, gender, civil status. What do I mean by factors? Factors are variables that can be used as classifiers. So categorical siya, character variable siya, pero pwede siyang gamitin as classifiers. Not all character variables, guys, can be considered as factors. Example, if you have in your data the address of the individual, suppose we're getting information about the individuals, tapos kinukuha natin yung mga addresses, and then most probably, guys, yung character variable na address, malamang hindi siya gagamitin as a factor unless gusto nating classifier yung address ng mga tao. Okay, but that might be far-fetched, no? So, ano yung mga categorical variables of pwedeng factors? Example, ito, race. No? So, ang race dito, either white or non-white. So, you can use this as a variable, as a factor variable. Kasi, pwede natin i-classify yung mga respondents na either white sila or non-white. Okay? Or yung gender nga, pwedeng female or male, or yung civil status, pwedeng single or married. So yung mga ganong klaseng variables, guys, they are what we call factor variables because they can be used as classifiers. Unlike, guys, yung sinasabi natin kanina, yung address. Okay, yung address, guys, character din naman yun eh. Kasi I'm talking of the complete address, no? Nyari 1, 2, 3, 4, ABC Street, okay, say Manila, etc. So that can be, that's a character variable. Hindi naman siya quantitative, hindi naman siya integer, hindi naman siya numeric, no? And unless you're going to use that as a classifier, then okay na gamiting factor yon. Okay? Otherwise, guys, hindi siya factor. So ang pwede lang natin gawing factor, yung mga pwedeng ginagamit na classifiers. For example, dito kung may religion, kung may Catholic, Protestant, Baptist, INC, Muslim, or whatever religion, guys, ang kasama dito as a variable, edi pwede natin gamitin as factor yon. Okay? So clear so far, guys, yung distinction ng factor dun sa ordinary na character variables. Kindly chat please kung clear yung paggamit ng factor. Kindly chat please. No questions ba? Clear ba so far? Okay, thank you. Thank you. All right. Okay, let's wait a few more seconds for the others. Kindly please feedback. All right. Salamat ha. Okay, so I hope that's clear, guys, yung factor na yan. That's why what we did last time, so I'm just reviewing what we did last time was to convert, no? I think we did this. We converted the variable, ito no, wage, dollar raise. That means this is from the data wage, yung object natin yung wage andi dito. And then specifically the raise variable. And then we converted it into as a factor. As factor, wage, raise. Kasi guys, kung hindi natin i-convert as a factor yan, hindi natin siya magagamit sa regression natin. So dapat pag may mga character variables na ganito na pwede i-classify, then we're going to use that as predictors also. Okay, so we did that last time. So let me convert them again here. Let me run that. Okay, so if I check yung class, guys. Okay, so factor na siya. No, kanina ano yan? Character siya. Ngayon factor na siya. And if you get the structure, okay, so sa education, integer, sa experience, integer, tenure, integer also, si race, si gender, at saka si civil status, lahat sila factors na. No? Number of dependents, integer, and then hourly wage is numeric. All right. Now, this is what I said last time. No? Let's have a quick review. Hindi natin pwede, guys, kunin yung correlation ni, for example, education at saka ni hourly wage. Okay, hindi maintindihan ni Arto. Kasi wala naman tayong object na education dito. So if I run this, okay, so ano mangyari? Nag-error siya, no? Error. Okay, object hourly wage not found. Now, bakit hindi siya makita? Wala naman talagang sa global environment natin dito, no? Walang wage. Kasi wage is part of walang hourly wage kasi hourly wage is part of the data set wage. Yung wage ang nare-recognize ni R, no? So if you want this, guys, if you want this function, you will have to attach yung wage. Sabi natin, the function of attaching a particular data set is that yung mga succeeding codes natin when we're referring to particular variables in that data set, maintindihan ni R. So hindi natin kailangan i-define na si education, si hourly wage are all coming from the wage data set. So if we do this, okay, I'm sorry, ginuko lang pala siya. Okay, if we attach wage, so pag kunin natin correlation nito, pwede na, no? Pwede na. Of course, correlation ni wage. Okay, bakit si wage kasi data set, di ba? If you get the correlation of wage, hindi pwede kasi wala namang correlation ang character variable, ang factor. Di ba yung wage natin, ito siya, may mga variables na hindi numeric, no? So you cannot get the correlation of a non-numerical variable. So what we have to do is to subset natin. Ang gagawin na lang natin, ang kukunin natin correlation ni wage is that lahat ng rows ng dataset natin and then ima-minus natin minus C 4 to 6. Diba? Bakit 4 to 6? Kasi yung factors natin is row 4, row 5, column 4, 5, 6. So we're removing column 5 to 6, that one. Okay, so pwede na natin kunin correlation ito. Yan. Round natin into 3. Round 3. Tama ba? Correlation. Okay, tama to. Okay, yeah. 3 decimal places. Okay, so we can see here, guys, we want the correlation of your dependent variable to be as high as possible, no? gusto natin na mataas yung correlation niya with the independent variables. Here you can see na si education ang pinakamataas na correlation with with hourly wage, no? Ang pinakamaliit si number of dependents. So if we're going to just use one model, okay, just use a simple linear regression, then si education ang pinakamagandang predictor based on correlation. 0.4 yung correlation niya. While the rest, pinakamababa si number of dependents, 0.05 lang. Next is tenure. Tapos si experience mababa din, 0.11. Okay. Then, sometimes, guys, okay lang na mag-a-attach tayo ng, ng variable, ng data, ng data frame, if that's the only file, that's the only data that we're going to use for our modeling. So, pag ganyan, guys, okay lang na naka-attach siya. Pero pag maraming datasets ang ginagamit natin, okay lang na i-attach muna natin, tapos kailangan i-detach natin, no? If we're going to make use of other datasets. Otherwise, baka magkaroon ng error, no? So here, i-detach ko lang siya just for the practice. Okay? So ibig sabihin nito, pag kinuha ko ulit yung correlation ni education and hourly wage, hindi na ulit siya mag-work. Bakit? Hindi na ulit na recognize ni R si education at saka si hourly wage kasi dinetach na natin siya. Okay? Alright, so here guys, ang ginawa natin, magre-regression tayo, no? We're going to regress hourly wage and education. We're going to use that from the stats package yung LM. Although hindi na natin kailangan ilagay ito, no? Yung stats na to. Kasi this comes already preloaded with RStudio, with R and RStudio. So I just show this to you para alam nyo kung saan galing yung LM na function. Yung LM is linear model. Okay? So we're creating an object called mod1. And si mod1, ang laman niya, yung regression ni hourly wage tilde education. So this is your dependent variable and tilde refers to regression using education as your independent. And then our data is wage. Okay, so last time I think we did this, di ba? Pag linagyan natin ng parenthesis yan, guys, ibibigay sa atin yung partial na results. No? Okay, tingnan niyo to. When I place the parenthesis there, nagbigay siya ng partial results. Yan. It gave us the intercept, beta null, at saka yung beta 1. Okay, and it gave us the, hindi. Ang binigay lang sa atin yung intercepts lang. Ito lang. This. If I want the whole output, guys, we use summary ng model 1. Okay, so ito yung mas kompleto na output. So first, there's the call. Okay, ito yung formula natin. And then the residuals. Okay, and then we looked at the ang tinignan natin dito yung values ng coefficients natin, ng parameters natin, negative 0.9 at saka 0.54. Okay, you have the standard error and then the t-value and then the probability. The t-value is obtained by dividing your b by the standard error. So if you divide this 0.90 divide by 0.68, you get negative 1.31. Okay, ito ngayon yung basis ng pag-compute ng probability. Dapat yung t-value mga 2 yata, 2 or 2 something, no, para maging 0.05 yung probability. Education, t-value is 10, no? So okay to. Kaya ang probability niya less than 0.05. Okay, so quickly now, we have a model, no? Ang model natin, sabi natin dati, is our hourly wage is equal to negative 0.90 plus 0.54 times education. So that's our simple linear regression. So hourly wage is equal to, copy this, this is times education, okay? And then plus a certain error term. Okay, so let's first understand what this is. No? Now, you estimate, notice that the intercept is not significant. Diba dapat 0.05, less than 0.052. Sabi natin, ang null hypothesis dito is beta null, the intercept, is equal to 0. So we fail to reject the null hypothesis kasi ang p-value niya 0.187, which is greater than 0.05. Okay, ibig sabihin nun, there's a probability that the intercept or B0 is equal to 0. Okay, it's equal to 0 siya. Kaso guys, kahit na yung intercept, it's not significant, we usually add it, sinasama pa rin natin siya sa model. Unlike yung mga predictors natin, no? Pag yung predictor is, the p-value niya is greater than 0.05, then we do not include it in our model. Only those predictors that are significant, statistically significant, are included in the model. So education, guys, since this is less than, way less than 0.05, no? Ano ibig sabihin ng 2e to the negative 16? Okay, you start with 2 here, 2, and then you move. Yung negative dyan, ibig sabihin 2 places to the left, no? Up 16 places to the left. So that will mean a decimal and then 15 zeros and then 2. Okay, so that's a pretty small number, practically 0. No? So si education, significant. Okay, what did you say was the meaning of ano? Anong meaning nitong, let's start with education. Anong ibig sabihin itong 0.54? Anyone, please? What's the meaning of the slope coefficient na 0.54? Anyone? Hello, guys. Na-discuss natin to, di ba, last time, yung 0.54 na to. What's the meaning of 0.54? Anyone? Okay, first question, is education statistically significant predictor of hourly wage? AKA, pag gumawa tayong model, kasama ba dapat siya? Okay, thank you. Thank you, John. Thank you, Sid. Yes. Now, bakit yes? Kasi, sabi natin, ang basis natin, either the t-value or the p-value. So, if the p-value, usually ang ginagamit natin p-value, sabi natin, if the p is low, when we say low, dapat less than 0.05 siya, the null must go. Ano yung null hypothesis natin dyan sa education? Our null hypothesis there is that B1, bakit B1? Kasi si education naman yung unang independent variable natin, kaya B1 yan. Yung B0 kasi yung intercept. No? B1 is equal to 0. And our inference is that we reject that null hypothesis that B1 is equal to 0. Reject natin yun. There's strong statistical probability that education is a value other than 0. In fact, ang point estimate niya is 0.54. So second question, ano ibig sabihin ng 0.54? 0.54 is the marginal effect of education on hourly wage. It means that for every 1 year increase in education, I'm using year kasi education is the number of years. No? For every 1 year increase in education, there's a corresponding 0.54 or 54 centavos increase in your hourly wage. So yung coefficient na to, guys, that's the partial contribution on our dependent variable education on the dependent variable which is hourly wage. So ibig sabihin, on the average, kapag nagdadagdag tayo ng, if a respondent has an increase in education, a 1-year increase in education, then his hourly wage will increase by $0.54, no? Or 54 cents. And then ceteris paribus. Now, I'm including ceteris paribus, and ibig sabihin nun, all things being equal. Ibig sabihin, kung may iba pang independent variables na kasama dyan, dapat hindi sila magbabago. Constant dapat sila. Kasi dito, ang sinasabi natin, pag nag-increase si education ng isang taon, mag-i-increase si hourly wage ng $0.54. Okay? On the reverse, guys, if education decreases by 1 year, if that's possible, no? Kasi kunyari, kung may education ka na ng 13 years, hindi naman pwede maging 12 years on. Hindi siya pwede, no? But that's just theoretically speaking. Okay? Okay, questions, guys? So far, clear ba? Paki-chat naman, please, so para alam ko kung if you're able to follow. Don't be ashamed, guys, if you want to ask questions, please. Okay, thank you, Mark. How about the rest, guys? Sid, thank you. Okay, John, thank you. RJ, okay. Good. Good, Mark. Jarod, Mark, okay. Okay, salamat, guys. Salamat. No? I really appreciate you giving the feedback. Okay, so we have been able to describe this, no? Ano yung interpretation nito? Yung 3 stars dito, guys, just look at this, no? Yung 3 stars, ito yun, yung 0.001. Okay, the 2 stars refer to 0.01, the 1 star refer to 0.05, the dot refers to 0.1. So nasa range siya between 0 and 1. So ano ibig sabihin ng 3 stars na to? Si education is significant at the 0.001 level of significance. No? Okay? Right. But para sa atin, guys, kasi 0.05 ang significance level na usually ginagamit, 1 star will be fine. 3 stars, 2 stars will be much okay. Okay, ano naman to? No? Ano to? You have the residual standard error, 3.378 on 524 degrees of freedom. Saan nanggaling 524 degrees of freedom? Saan nanggaling yun? Paano nakuha yun? Okay, so that came from n minus k minus 1 yan. No? Okay, ano yung n? N is the number of respondents. Ilan ba yung sample size natin? 526. Di ba? So 526 minus k. Ano yung k? K is the number of predictors. So ilan ba yung predictor natin? Isa, si education. So that's minus 1. And then minus 1, okay, to compensate for the degree of freedom lost because i-compute pa natin din intercept. No? So 526 minus 1, doon na galing yung 524 degrees of freedom. Okay? Multiple R squared 16%. Adjusted R squared 16.32%. Okay. Ano ibig sabihin ng adjusted R squared or multiple R squared? Usually, ang ginagamit natin dyan yung adjusted R squared. 16.32%, guys, what does that mean? It means that 16%, 16.32% of the variability of the dependent variable, which is in this case is hourly wage, can be explained by our independent variable, which is education. Okay? So that's the meaning of 16.32%. Dalawang klase siya, no? Yung R squared and then the adjusted R squared. what's more relevant for us is the adjusted R-squared. And this is really more important kapag multiple linear regression. Kasi guys, pag dagdag tayo ng dagdag ng dagdag tayo ng dagdag ng variables, kunyari 100 ang gamitin natin. While it's true that your R-squared will increase. Kasi di ba technically the higher the R-squared, the better the model is. Why is that so? Kasi pag mataas yung R-squared, ibig sabihin yung model natin kayang i-explain yung that amount, that percent of the variability of your dependent variable. Okay, so let's suppose we have 100 variables na ginamit to explain hourly wage. And the multiple R-squared is 98%. And that's very good, guys. Kasi yung model natin kayang i-explain yung variation, yung variability ng dependent variable natin, hourly wage, 98% nun kaya niya. Ibig sabihin, 1+% na lang ang hindi niya kaya. Okay? So, what happens, guys, if we keep on adding predictors, okay, tataas yung R-squared natin. Kaso, this goes against the grain of a parsimonious model. No? As much as possible, guys, parsimonious dapat yung model natin. Parsimonious, the parsimonious model. What does parsimonious model mean? Well, ang literal na pag sinabing parsimony, guys, yung pagkakuripot, no? Ang ibig sabihin ito, the less predictors, the better. Kung kaya naman i-explain ng model na tatatlo lang yung predictors compared to 100, edi mag 3 predictors lang tayo. Kasi imagine, guys, kunyari nagsa-survey tayo. Tapos 100 yung independent variables natin. So 100 na independent variables yung kukunan natin ng data, di ba? So that can be very, very difficult. No? Time consuming, it's expensive. And it does not guarantee, guys, that our model will be better if we use 100 independent variables compared to, let's say, 50 independent variables. Okay. Now enter adjusted R-squared. No? So, ano yung adjusted R-squared? Pinipenalize natin, guys, yung model natin for adding more variables. Okay, in a nutshell, yun ang ibig sabihin ng adjusted R-squared. So, it's more useful to use the adjusted R-squared. Kasi sa adjusted R-squared, guys, pinipenalize natin kung magdadagdag tayo ng independent variables, okay, possible na bababa yung adjusted R-squared. Okay, ibig sabihin nun, hindi na nakakatulong yung pagdagdag natin ng independent variables. And there's a formula for that. We'll take a look at that siguro in the next few sessions. Okay, so let me pause for a while. I hope that everything is clear here, guys. Lahat ng mga components dito. Ito na lang pala yung FSTAT. Saan ginagamit tong FSTAT na to, guys? Saan ginagamit? Kasi dalawang test ang ginagamit dito. Ito yung individual t-test. Yung components, yung natin predictors natin kasama yung intercept, tinetest natin siya for significance, using the t-value, using the t-stat. Ito naman, guys, this is what we call overall goodness of fit, yung F-stat. So that's your ANOVA. So may ANOVA tayo dito, no? Automatic na nag-ANOVA pag nagre-regression. Analysis of variance. Ito yon. And ang ginagamit niya is F-stat. Ang null hypothesis niyan, guys, may null hypothesis yan. Di ba? Pag statistical test, lagi may null hypothesis yan. Ang null hypothesis niyan is that beta null, which is your intercept, is equal to beta 1 is equal to 0. Yan ang null hypothesis. Unlike ito, guys, yung individual t-test. Ang null hypothesis nito, in this case, dalawa. B sub 0 is equal to 0. Tapos dito naman, B sub 1 is equal to 0. Dito combined. Okay? Combined. That's why this is called the overall goodness of fit. Goodness of fit test. Ibig sabihin yung overall model natin. We're taking a look at both BO and B1 and then equate it to 0. So what's the answer to this hypothesis, guys? Ano yung answer natin dito sa hypothesis na to? Tingnan natin, no? Okay? P-value is practically zero. Therefore, we reject this null hypothesis. We are rejecting the null hypothesis that beta null is equal to beta 1 is equal to 0. We believe that at least one of this, no? Hindi natin alam kung sino, no? But at least one of that is statistically significant. And true enough, guys, education. In fact, education is not equal to 0. 0.54 siya dito. And it's statistically significant. Okay? So ang kinompute yung F-stat, it's 103.4. And then, ang F-stat, guys, dalawang degree of freedom. DF1 and DF2. Okay, yung DF1 natin will be the number of predictors. Ba? So bakit 1 siya? Kasi 1 lang naman yung predictor natin. Okay, isa lang naman yung predictor natin, si hourly wage. Hindi naman kasama si intercept. And we have the degree of freedom 2, which is sure, alam na natin to n minus k minus 1, di ba? Okay? Pareho lang to ng 524 dito sa ano, sa degrees of freedom natin sa ano, dito sa residual test natin. Okay? All right. So I hope that covers, guys. I hope naintindihan natin yung ano. Ito pala linagay ko dito, no, ANOVA test. And then sometimes kasi, guys, yung mga yung output ng LM, guys, hindi maganda eh. Kaya mas maganda kung gagamit tayo ng mga tools, for example, itong JTools. Okay, from the library JTools. Tingnan natin kung ano mangyayari sa model 1 natin. Tira natin 'to. Okay, so hindi ko pa na-install si JTools kasi nga nagbago ako ng ano, install that packages JTools. Okay, question lang, guys. Did we discuss this last time? Itong JTools na to? Pa-feedback naman, please. Oh. Ah, hindi. No, sorry. I wonder what file I'm using. Anyway, guys, pakiran na lang din to, no? Paki-insert na lang dun sa ano nyo, sa files nyo. I-install nyo muna si JTools. And then once it's okay, na-install lang sa akin. Once it's installed, you can require JTools. Okay, rin-require ko na siya, library. Tapos, we're going to use the sum SUMM function of JTools. Isa-sum natin siya sa model 1 natin. And here you can see the output is a lot better. No? So presentation ready na to. Andiyan yung model fit natin, F, rightly, degree of freedom 1, degree of freedom 2 is equal to 103.36 with P is equal to 0.00. R squared is 0.16, adjusted R squared is same lang na 1.16. Tapos andito yung table ng intercept natin, standard error, p-value at saka p-value. Okay, please chat, guys, if you have done it. Paki-chat, please, guys, if you're done. Chat. Let's wait for the others. Okay, thank you. A few more seconds, guys, and then we continue. How about the rest, guys? Kindly give feedback, please. Okay. Thank you, guys. I hope the others are following also. Okay, let's proceed, guys. Let's proceed. Okay, tanong ko lang, guys, kung... Sige, I think we also discussed this, di ba? Now, it's important, guys, kung titignan natin, nag-create tayo, di ba, ng object, yung mod 1, which is the result of the regression. Let's first check kung ano yung laman ng mod 1 na to, no? So, if we ask yung mga names niya, so may mga laman siya, no? So, it's actually a list. Sabi dito, mod 1, list of 12. So, if I click this, diba, oops, sorry. If I click this, ano ba yung click ko? Ito pala, sorry. Yung wage pala click ko. Okay, so this is, I click the mod 1. Okay, you notice, guys, that it's a list. So may mga laman siya, may mga integer, may formula. Okay, so iba-iba yung laman niya. Okay, and then we can access yung mga laman nito. Okay, so for example, mod 1, kasi may coefficients, di ba? If I run this code, mod 1 $coefficients, then it will give me the coefficients. If I run the residuals, okay, ibibigay niya yung mga residuals yan. No? Ano yung residuals, guys? The residuals are the error terms. Ito yung deviation, ito yung difference ng actual value ng hourly wage with the predicted value of the hourly wage. Kasi di ba may actual value tayo, di ba? So we have this actual value, ito 3.1 na to. Then we have the model value. No? Ibig sabihin, meron tayong, okay, let's just quickly do that. No? Okay. So ano ba yung coefficients natin? Okay, ito, no? Let me just copy this, Control C, Control V. Okay. And then I'm going to compute for the, so observation number 1, yung wage. So the education is 11. So I'm going to multiply this 11. Di ba ito yung model natin, negative 0.9048517 plus the slope times education. For the first respondent, ang education niya 11. So if I run this, okay, so this is the predicted value. No? Predicted value to. Eh, ano ba yung actual value? 3.10, Control C, Control V, minus, and let me copy this. Control C. Okay, so this is the actual value minus the predicted value, and you have negative 1.95. Okay, so if I take a look at, okay, tingnan natin yung head ng mod 1 residuals. Okay, yung first 6 lang tingnan natin, ha. And first 6. Bakit ayaw? Sorry, mod 1 pala to. Mod 1. Maling code ko. Okay, take a look at it. So ito yung mga, oops. These are the residuals, no? Negative 1.95. And true enough, guys, ito yung computation natin. Okay? So that's how the residuals are computed. You compare the, the actual value with the predicted value. Saan nanggagaling yung predicted value? Dun sa model. Diba? Kaya kailangan magmo-model muna tayo, magre-regression model tayo, and then we're going to use that model in order to predict our dependent variable. So pag may prediction na tayo at saka may actual value tayo, yung difference nila, actual value minus the predicted value or forecasted value is equal to your residual. Okay? So yung mga actual value, andi dito din yun, no? Ito. Kunyari, gawin natin tong head, no? Let's just take a look at the yung mga na lang. Sorry. Fitted values are your are your predicted values, no? Diba kanina predict natin 5.05, ito yun, 5.05. Yun yung mga predicted values natin. And yung fitted values. Okay? And then you have measures AIC and BIC. Yan, AIC at saka BIC. Now si AIC, guys, is AKIK information criterion. And BIC is Bayesian information criterion. Okay. Saan ginagamit tong AKIK at saka Bayesian? Ginagamit siya, guys, pag nagko-compare tayo ng models. Okay, kunyari may model, may models tayo na of course dapat pareho yung dependent variable nila. Okay, pwedeng magkakaiba yung independent variable. So and then we check, guys, yung AKIK nila o kaya yung BIC nila. Whichever model has the lower AIC or BIC, siya yung mas magandang model. Okay? We'll have an example of this. All right. So this one, I think we plotted it last time, and then yung residuals, tinignan din natin. So let's skip that for a while. Punta na muna tayo, guys, sa punta na muna tayo sa asa na yung multiple regression natin. Okay, ito. Which is, nasa anong line yan dito sa natin? Okay, ito. I think 115, 116. Okay, multiple regression tayo. So let me just use this. Okay, we don't need to do this kasi na-convert na natin into factor. But just checking, check na natin, guys, kung check na natin yung class. Okay, structure na lang. Yung structure ng wage. Okay, factor na, no? Factor na si race, si gender, at saka si civil status. So, no need to run this. Okay, so we're going to here, no? Pwede natin i-check yung correlation using the pairs package, no? Site package, and you don't need to install this kasi it comes preloaded with R. And then we're going to use the pairs.panel. Let's run this. Okay. Ito, guys, yung as compared kanina yung correlation lang, mas maganda yung pairs.panel, no? Same lang naman yung yung result. But this is more graphic. Okay, now of course, guys, yung yung itong race, gender, at civil status, it does not have any meaning, no? Yung correlation na yan. But still here, nag-attempt siya mag-compute. But if you don't really want that, so gawin natin yung psych pairs.panels. Okay, so ang kailangan lang natin si wage. Okay, subset natin, yung ginawa natin kanina, no? Lahat ng columns, and then tatanggalin natin si 4 to 6. Yan. Okay, parang yung kanina lang, tinanggal na natin yung mga factor variables. No? Okay, let's see this. Okay, ano nangyari dito? Ay, mali. Sorry. Negative dito. Okay. My mistake. Sorry. I just run this. Okay. Now, we can see here, guys, na mas relevant na itong ano natin. Kasi wala na yung mga factors. So, ito yung pairs.panel. It will show us yung correlation and even the plot. So, this is education with experience. Ang correlation nila, -0.3. Okay. Si hourly wage, correlation with number of dependents, -0.05. With tenure, 0.35. With experience, 0.11. And as expected, guys, alam na natin to, 0.41, the biggest. No? Now, we want, as I said, guys, we want the dependent variable to be as highly correlated as possible with the independent variables. But the independent variable, we don't want them to be correlated with the other independent variables. Kunyari to, guys, experience at saka si tenure. Okay, 0.5 siya. Okay, so we don't want that the independent variables are highly correlated. Kasi that can be a problem as far as yung isang assumption natin ng classical linear regression model, which is yung multicollinearity. Okay? All right. So, ito pala sinurod ko pala dito. Okay, we go now to regression. Okay, how do we now regress? No? So we're creating another model to LM, hourly wage regressed on education, experience, tenure, race, gender, civil status, and number of dependents. Data is equal to wage. Okay, and then here, yung open and close parentheses, that is to print the coefficients. Okay. So, yan na guys yung yan yung mga coefficients natin. Si intercept, -3.38, education, 0.57, etc., etc. Okay, may mga nakikita natin na negative, no? And then, if you notice guys, dito, may mga bago ng variables. No? Race white, gender male, civil status single, at saka number of dependents. Yung tatlong to, parang hindi pa natin nakita to. Although may race na variable, may gender, at saka may civil status. Okay, so let's interpret this first. Yung ano pala yun, yung print out. So we know that mod 2 is a list. So yun yung class niya, di ba? I run this. Class LM pala siya, no? And then ang names natin sa module 2 yung pareho ng kanina. If you get the summary of module 2. Okay. Ito na yung kailangan natin, no? Okay, so this is our rewrite ni R yung yung formula. Okay? And then, ito na guys yung ano, yung regression results. Okay, let's take a look at this. Okay, may mga strange na nangyari dito, no? Tingnan nyo, yung race white, gender male, and civil status single. So what are these, guys? Ano tong mga to? How do we interpret this? Okay, let's start with the tingnan nyo sa intercept, no? Ano nga pala ibig sabihin ng intercept? The intercept is the value of your dependent variable, in this case, yung hourly wage, when all the regressors are equal to 0. So, ibig sabihin, 0 education, 0 experience, 0 tenure. So, mamaya explain natin kung ano yung sa race, and then 0 of number of dependents. Okay, that's the value. Kaso guys, we cannot put really too much pragmatic interpretation or meaning to this. Kasi negative 3.38, no? Ibig sabihin nun, yung tao pa yung magbabayad sa ano, sa company, which is of course absurd. Okay, so yung intercept, although kasama siya sa model, we don't really put so much emphasis on that. Okay, so let's go. So nakita natin dito guys, yung intercept naging statistically significant na, no? Kanina hindi siya significant. Okay, how about education? Education. Can somebody please interpret what's the meaning of education? Anyone? Please, volunteer. Okay, tatawag ako ha. Okay. Anyone? Sige, Mark. Mark Mariano, could you try to explain ano ibig sabihin nitong education na 0.574?
Hi, sir. I think you would assume as the independent variable po.
Pero anong, yeah, you're correct, no? Education is an independent variable. But how about yung 0.57? How do you interpret that?
For every movement po in the model, there is always an increasing 0.574 in the model po.
Okay, sige. Thank you, Mark. Thank you. Okay, so we'll improve on Mark's partly correct naman yung kay Mark. I-improve lang natin yung answer niya, no? But it's okay, Mark. Thank you so much. Now, first, significant ba yung education, guys? Is education a significant predictor of hourly wage? Yes or no, guys? Class? Okay, thank you. Yes. Yeah, correct kayo, no? Thank you, John. Thank you, Jonas. Yeah. Thank you, Mark. Yeah, salamat. Tama, statistically significant siya. 3 stars, so, di ba? Significant to at the 0.001 level of significance. No? Okay, mataas yung t-value niya. No? Okay. Alright. So, by the way, guys, kailangan alam natin kung ano yung minimum na t-value para siya maging significant. Please do some research on that. Okay, 0.57. Anong ibig sabihin nito? How do we interpret this? So, susulat ko, guys, ha? For every 1 unit increase in education. Now, si education kasi, this variable is measured in years. So dapat ang pag ano natin ng change ni education is also in number of years. For every 1 year, no, increase in education, okay, there is a corresponding what? Since the hourly wage dollar to, no? So $0.57 or 57 cents increase. Bakit increase, guys? Kasi positive siya. No? So ibig sabihin, pag nag-increase sa education ng 1 year, si hourly wage mag-i-increase din ng 1 year because it's a positive correlation. Pag negative yan, reverse yung mangyayari, no? Pag nag-increase education ng 1 year, hourly wage will decrease, no? Okay, increase kasi positive to. So, there is a corresponding 0.57 centavos increase in hourly wage, no? And then we have to put here ceteris paribus. Okay, ano ibig sabihin ng ceteris paribus, guys? What does this mean? Ulitin natin ha. For every 1 year increase in education, there is a corresponding 0.57 or 57 cents increase in hourly wage, okay, comma, ceteris paribus. Ceteris paribus means, guys, that all things remaining the same, all things being constant. Ibig sabihin, si education lang dapat ang i-increase natin ng 1. The rest, hindi natin i-increasean siya. Constant pa rin siya. Walang increase kay experience, walang increase kay tenure, walang increase kay race, gender, civil status, etc. Si education lang mag-i-increase ng 1 unit or 1 year. Okay? Is that clear, guys? So that's how you interpret, no? Yeah, thank you. Shallow, all things constant. Okay. So guys, kailangan kasi sa sa take home group assignment, dapat alam natin i-interpret yung mga predictors natin. Okay, so experience, guys. Statistically significant ba? Is it statistically significant? Yes or no? Okay, no? Okay. So depende, guys, kung ano yung level of significance natin, yung alpha natin. A level of significance, if you recall from your stat, it's your alpha. If you're using an alpha equal to 0.05 or 5% significance level, okay, hindi significant to. Kasi dot lang siya. Dapat 1 star siya. Okay, so let's just maintain, guys, let's just maintain yung 5% level of significance. So this is not statistically significant. It's experience. And it should not form part of the model. Okay, next. Tenure, guys, tenure. Statistically significant, yes, at 0.001. No? Interpretation ng 0.138. Ang ibig sabihin nito, guys, for everyone, now ano yung tenure? So dapat alam natin, guys, yung dimensions ng mga independent variables natin. Tenure is years, no? So for every 1 year increase in tenure, there's a corresponding $0.138 increase in hourly wage, guys, comma, ceteris paribus. Okay? Ceteris paribus. So that's how we interpret it. Okay, so meron tayo dito, no, yung tatlong factors. Diba? Yung tatlong factors kasi sinama natin yan sa regression. Ano ba yung tatlong factors natin? Okay, here we have race, we have gender, we have civil status. Okay, so what happened here, guys? Bakit ang lumabas dito? Bakit ang lumabas dito? Race, white, gender, male, civil status, single. Ano nangyari dun sa iba? E, tingnan muna natin, guys, si race. Okay, ano yung mga components ni race, guys? Dalawa siya, di ba? Let's see. Summary natin. Summary. Okay, tingnan nyo, guys. No? Summary natin. Si race, dalawa. No? Non-white, 54. White, 472. Si gender naman, dalawa. Female, male. Si civil status, married, single. So, itong mga factors na to, tagalawa sila. Okay? The factors can be more than 2. Pwedeng 3, 4, 5. Depends on the variable. In this case, guys, yung mga factors natin, tigdalawa lang. Okay. Now, what do you do, guys, with the factor? Anong ginagamit? Paano to? Kasi itong mga to, guys, character sila eh. Paano sila magiging predictor ni hourly wage? So that's why, guys, I said that factors are very important. No? Kasi magagamit natin yan to for our regression. We can use factors to be used as regressors dun sa model natin. Okay, tingnan natin, guys, kung ano ginagawa ni R. Non-white, no? 54, white 472. Okay, anong gagawin dito ni R? Ang gagawin dito ni R, guys, it will dummify the factors. No? Or in other words, it will introduce dummy variables. Okay. What do we mean by dummify the factors? Ang ibig sabihin ng dummify the factors, guys, kunyari, itong race na to, gagawin niyang pag dalawa, 1 or 0. Pag tatlo, 0, 1, 2. Pag apat, 0, 1, 2, 3. No? So it depends. And then, sorry, I stand corrected. No? Whether it's 2 or 3, guys, or 4 factors, gagawin niyang 0 or 1. Okay? So what do you mean by dummify, guys? Gagawin niyang 0 or 1 si white at saka si non-white. Now, how does R do it? Ano ginagawa ni R? So ang gagawin ni R, guys, titingnan niya, no? Sino dito yung alphabetically mauuna? Sino yung alphabetically mauuna? Si non-white. Therefore, guys, tingnan mo naka-alphabetically no? Ang gagawin niya, pag ida-dummify, ibig sabihin, papalitan natin yung itong race, papalitan natin ito ng dummy variables. Okay. Ilang dummy variables? The number of dummy variables will be n minus 1. What do you mean by n? Ilang factors? So ilang factors ba to, guys? Ilang factors to? Dalawa. So ilang dummy variables ang ipapasok? Ilang dummy variables? 2 factors minus 1. So isa lang. I-move ko nga ng konti muna dito. Hindi siya na-move. Okay. So sabi natin, 2 factors minus 1. So ang mangyayari niyan, isa na lang. Isang dummy variable. So papalitan ni R to, itong race na to, ng dummy variable. Okay, and what will happen is that yung mauuna, si non-white, no? Non-white, no? Si non-white, siya yung magiging 1. Siya yung magiging benchmark. Ang tawag natin dyan, benchmark, no? Or reference variable. Hirap pag naka-ano lang. Benchmark, no? Benchmark or reference variable. So, ang mangyayari dito, guys, paano gagawin yung dummify or dummy variable? Tingnan natin. So, ito, guys, white. White siya, so 0 yan. Isi-zero out niya yan. White. So, lahat ng white, guys, gagawin niyang 0. Tapos, lahat ng non-white gagawin niyang 1. Okay? So, pause muna ako, guys, ha? Before I pause, uulitin ko yun. Pag mga factors, guys, what's being done is to dummify the factors. Ibig sabihin ng dummify, papalitan siya ng 0 or 1. So, depende dun sa factor. Pag dalawang factors lang, hindi naman, guys, kasi pwede magka-isang factor, ano? Ang minimum niyan 2. So, kung 2 factors, ilang dummy variables ang i-introduce? Isa lang. No? Isa lang. Kasi yung isa, siya yung magiging reference variable. So, dito, guys, alphabetically, mauuna si non-white. Siya yung gagawing 1. And then si white gagawing 0. Okay? On the other hand, dito naman sa gender, sino yung mauuna? Female. So ang mangyayari dito, si female ang magiging reference, si female yung magiging benchmark, no? So lahat ng female, ito magiging 1 siya. 1. 1. Male, 0. 0, 0, etc. No? So that's what happens, guys. No? So dito naman, si civil status, tingnan natin sino yung alphabetically mauna, si married. Siya yung magiging 1. No? So married. No? So lahat dito, pag single, 0. Pag married, 1. Okay? Single ulit, 0, etc. Okay, pause muna ako, guys. Clear ba? Clear ba yung pagdadamify ng mga factors? Paki-chat naman please, guys. Kung clear. Now, the time na. Okay, good, good. Okay, just one example, guys. Paano kung tatlo? Kunyari ang natin variable, yung year level. So meron tayong frosh, meron tayong sophomore, meron tayong junior, meron tayong senior. Okay. All right. So alphabetically, guys, mauuna si frosh, no? So yun yung magiging yan ang magiging benchmark variable. Okay? Siya yung magiging benchmark variable. Okay, so what will happen now is that so ano mangyayari? Ilang factors, ilang dummy variables ang i-introduce? How many? Paki-check nga please. How many dummy variables will be introduced? How many dummy variables? Ilan, guys? So, tatlo, no? Tatlong dummy variables. Yan. Tatlo siya. Bakit 3? Kasi di ba ang formula, the number of factors minus 1. So 4 factors minus 1, so 3. No? Okay, so it's already time, guys. I'll illustrate this next time itong more than 2 na dummy variables. But let me just show you, guys, ito kung ano yung interpretation nito. Okay, ano interpretation? Okay. How do we now interpret this, yung kanina? And we'll end in this. How do we now interpret this? Ito. Si race white. Okay, ano ibig sabihin nito? Okay, first of all, it's not significant, no? But assuming it's significant, ang ibig sabihin nito, guys, on the average, white people receive $0.11.10996 more than their non-white counterparts, ceteris paribus. So you're now going to interpret this in relation to your reference variable. So dito, guys, sa race, sino yung reference variable natin? Di ba si non-white kasi nauna siya alphabetically. So interpret natin to. Dito sinasabi na niya kung sino yung hindi reference. Si white yung hindi reference kasi alphabetically nahuli siya. No? So pag in-interpret natin to, ang sinasabi natin, yung mga white daw na tao, they receive $0.10996 more than the reference variable, which is yung non-white. Ito naman, si gender. No? On the average, male employees receive $1.75 more in terms of hourly wage than their female counterparts, ceteris paribus. And lastly, guys, on the average what? Single people receive $0.45 less, kasi negative, than their married counterparts, ceteris paribus. Okay? So that's how you will now interpret, guys, pag factors yung lumalabas, no? And again, what happens, guys, pag factors, ang ginagawa ni diyan, dinadamify niya. kino-convert niya yung mga factors into zeros and ones. And then, pag in-interpret na natin yan, it's always with reference to your benchmark variable. Si R, ang default niya, ang nauuna, ang ginagawa niyang benchmark variable, yung alphabetically nauuna. So again, guys, for the last time, this is interpreted as, on the average, white people tend to receive $0.10996 more than their non-white counterparts, ceteris paribus. On the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. And on the average, single people receive negative $0.46 less than their married counterparts, ceteris paribus. Okay? So we're going to continue with this next meeting. Okay? Itutuloy natin yung discussion na to. And guys, pag nagsimula na tayo next meeting, hopefully hindi ako magkakaroon ng problema sa sa pag-access sa Zoom. Kindly i-load nyo na yung wage dataset, tapos i-run nyo na rin up to that point na nag-model 2, yung multiple linear regression. Okay, so let me stop recording now. Okay.